Good day once again, my name is Graphics. Today we'll be looking at this example on motion. It says on a long straight road, a car accelerates uniformly from rest, right? Reaching a speed of 54 km per hour in 810 seconds. It maintained this speed for 3 km behind the truck until a suitable opportunity for passing the truck exists. The car then accelerates uniformly to 90 km per hour in further 10 seconds. If after maintaining this speed for 5 minutes, the car is brought to rest by uniform deceleration of 2.5 meters per second square, illustrates the motion in a suitable diagram and computes the total speed traveled, the total time taken, the average speed, and the acceleration in the first 300 seconds. So what you do here is this: you write out your parameters. You say the keyword is that we should compute in a suitable diagram, right? So now we're using our graphical representation of this question. Now if I have my velocity time graph this way, how good? This is my velocity and this is my time in seconds, and this velocity in meter per seconds. How good? Now it says the car accelerates from rest. How good? On a long straight road, the car accelerates uniformly from rest, reaching a speed of 54 km per hour. Reaching a speed of what? 54 km per hour. Now if you convert 54 km per hour into meter per second, it will be 54 multiplied by 1000 all over 3600, right? So if you do that, that is 54 multiplied by 1000 divided by 3600, you'll be having 15 meters per second. So that will be what? 15 meters per second. Are we good? So that means the first one here is 15 meters per second. In what? In 810 seconds. So this is 810. Now it moves forward. It says it maintained this speed for 3 km behind the truck. That means the speed was constant for 3 km. Now that means initially initial velocity was 50 meters per second, right? Now if you use your equation of motion to get the time, because it says maintain this speed, what speed? 50 meters per second. So my initial velocity was maintaining u is equals to what? 15 meters per second, right? Then we know that my velocity v is equals to what? Distance over time, or my speed v is equal to distance over time. Is that taken? Now the distance is covering is what? 3 km. Our d is equals to what? 3 km, which is giving me 3000 meters, right? So recall v is equals to what? Distance over time, right? So our time will now be what? Distance over what? Velocity. So what is the distance here? 3000, right? What is the speed here that is maintaining? 15 meters per second, right? So by the time you do it, 3000 divided by 15, we have 3000 divided by 15. That will give me 200 seconds. So the time here will be what? 200 seconds. Are we good? That's our time. So it maintained this speed for another 10 seconds, for another 200 seconds. So 200 plus 810, that'll give me 1010 seconds. Are we good? Now, behind the truck, until a suitable opportunity for passing the truck exists, the car then accelerates uniformly to 90 km. Now the car now accelerates again uniformly to 90 km. So if I convert my 90 km per hour into meter per second, it will be 90 multiplied by what? 1000 all over 3600. So when you do that, 90 multiplied by 1000 divided by what? 3600, and we're having 25 meter per second. So that will give me 25 meter per second. So it maintains this guy here for another 25 meter per second. Are we good? So if we bring this down, in further 10 seconds. So 1010 plus 10 will give you 1020. Are we good? Now it moves forward again. It says after maintaining the speed for 5 minutes, it maintained the speed for 5 minutes, then it comes back to rest. So it maintained the speed for 5 minutes, right? So we know that 5 minutes is equals to what? 5 times what? 60 seconds. So we're having 5 times 60. 5 times 60 will give me 300 seconds. So 5 minutes is 300 what? Seconds, right? So it maintained it for another 5 minutes, which is 300 seconds. So we're having 1320 seconds. 1320 seconds. Are we good? So it maintained it for 5 minutes. The car is now brought to rest by uniform deceleration of 2.5 meter per second. So this car is now brought to rest by uniform deceleration of what? 2 meter per second. Now, you know very well that it is brought to rest by uniform deceleration. That means my A will go for what? Minus 2.5 meter per second. The initial that it was coming, it was maintaining what? It was maintaining 25 meter per second. I mean, the velocity the car was maintaining was what? 25 meter per second. This meter per second square here. Are we good? Then the final velocity, since it's coming to rest, is equals to what? 0. Now we're looking for the time at which it comes to rest. So using A is equals to what? V minus U over T. So this will give me V is 0, then U is 25 all over the T we don't know, right? But we know very well that our acceleration is what? Minus 2.5, which is equals to minus 25 over T, because 0 minus 25 will give you this. So if I cross multiply, my T will give me 25 over 2.5. That 25 over minus 2.5, and that will give me what? That will give me 25 over minus 2.5. 25 divided by 2.5. So that will give me 10 seconds. So my time is what? 10 seconds. So it comes to rest in another further 10 seconds, right? So we're having 1330 seconds. That will be the total time here. Are we good?